Hello everyone. In this video we'll be looking at two concepts. One is called as composition, the other one is called as inheritance. So we have all heard of inheritance, right? So some of the genes we derive from our ancestors, so on and so forth. We also get properties from that our ancestors have bought, and we can inherit that. We can inherit debt from our ancestors, so on and so forth. So we all understand inheritance is where you get something from up the tree, right, in the family. So that is kind of what inheritance is. In terms of object-oriented programming, we are going to look at what inheritance is. The other concept is called as composition. So I can give you a little example right here on my screen, if you can see on my whiteboard. So I have written like a person, that's a class. So we can have a person class, then we have a student class, and we have a faculty class. Okay, in terms of inheritance, so person is by itself an object, right? A person can have name, age, gender, so SSN, social security, address, so on and so forth. All those things apply to a faculty and a student also, because they are also person, right? So, but what a student or a faculty has unique, a person would not have, any person would not have. So let me go into the specifics of what I mean. So let's write some attributes for a person. So name, right? Date of birth, social security number, address. So let us say gender. Oh. Maybe race, so on and so forth, right? So these are some of the attributes that define a person. If you look at a student, all these apply to a student too. Name, date of birth, social security, address, gender, race are all applicable to a student also. On top of that, specifically, a student will have ID, student ID. Okay. A college they go to, or school, what school they go to, what is their major, what is their GPA, date of enrollment, academic standing, so on and so forth, right? So these belong only to the student. So if you take a person X, if X is just a person and X is not a student, okay, that person will have name, date of birth, social security, address, gender, race, okay? And if you take a student will not only have name, date of birth, SSN, address, gender, race, but he or she will also have student ID, school major, GPA, date of enrollment, and academic standing. So in short, if you look at, okay, just one second, just taking some time to refresh. Okay, so if you take a student class will inherit all of these properties and add to it. Okay, so let's now do faculty. So on top of whatever the a person has, a faculty is also a person, so they'll get all of that. On top of that, they probably will have faculty ID or something like that. School they go to, tenured, yes or no, are they tenured? What is their department, date of employment, experience, subject they teach, courses they teach, okay, and other things. So these are specific only to a faculty, right? So a faculty will not only get all of these, but they also have their own information. So this is we can achieve this kind of a relationship, right? Whenever you have this kind of relationship, you can achieve this just by providing this option to inherit. Okay, I'm sorry. So we are just providing an option for a faculty class to inherit from the person class, a student class to inherit from the person class. Note the direction of the arrow. The inheritance flows top to bottom. Okay, a person has no idea about a faculty class. A person class has no idea about a student class. Okay, if you define somebody as a person, they are just a person, they are not a faculty. So the objects, even though in real life a person can be a faculty, faculty can be a person, when you write in object-oriented programming, a person class and faculty class means faculty class, if you create an object from faculty class, like there is a faculty called Manjula Chandrasekharan, she will have name, date of birth, social security, address, gender, race, and faculty ID, school, tenured, yes, no, all those questions available. But if a person like James Smith is just a person, not a faculty or a student, he will not have any access to the other information because of the class he derived from. Okay, so you have to remember that when we say inheritance, it flows from top to bottom. Faculty class knows about person, student class knows about person, but person class does not know or care about student or faculty class. This is called as inheritance. Okay. Okay. So the advantage of inheritance, you not only get the properties, any methods that are there in the person class, you have an option to reuse them as it is. You also have an option to override them and customize them so they'll work a certain way. So for simplicity's sake, we are keeping it in this level, but you can inherit the methods. You will inherit the methods. The faculty class will have all the methods of the person class. Unless it's like a private method, then nobody has access, right? So anything that is just you don't write like methods that are like not available for your child classes. Mostly like that's really not how it is done. The idea is to reuse things. So this person could be a pilot. There could be a class called pilot. You can still reuse the person class, get all this information, and then override some methods for a pilot, maybe additional background checks or some qualifications, stuff like that we could add. So you can keep extending. So you're building layer upon layer upon layer. So that is what inheritance is all about. So that is what inheritance is all about. So if we were to go to composition, so we can use similar example for composition. We could use the same example like person. So we just said the person class can have name, date of birth, address, SSN. Then I said race, gender, so on and so forth, right? So when we think of a person, these are all some of the properties for this particular class, right? So if it's a name, it's going to be of type string. Date of birth will be date time, that's the type. SSN is going to be numbers, so integer. No, it's actually string. Well, let's think about it. So you could do it as a string or an integer, it doesn't matter, but it's just 9 characters. Because usually it's numbers, we'll call it integer. The race will be some kind of string. Gender is going to be some kind of string. So these are data types. If you watch, the one data type I have not defined is address, and I'll tell you why. When you look at address has what is it called, line 1, line 2, or it's called like street, right? Then we have city, state, zip code. Okay, so this by itself is a complex type. How do you put all of this inside one field? Okay. Somehow this whiteboard is like stuck. Not sure why. See, it is still stuck. Okay. So the idea is that if you were to like look at person class, address by itself is complicated. Okay, so this address will have all these things inside. Okay, so if you just want to say address, the address should have street number, street line 1, street line 2, city, state, zip code at the bare bone, right? So this adds complexity. So each, the street will be string, city will be string, state will be string, zip code will be a number. So one element, one address has multiple one address has multiple fields inside. Okay, that makes itself an object. So address here is an object. So what happens is, so we have a person, oops, we have a person class, and inside the person class we have an object called address. Okay, so composition is where one object is inside another object. So there is a person class, and the person class has an object called address. So this address is not a string, it is of type address. This address is going to be a class by itself. So you have a person class and address class. Okay, so that is called composition. So where one object is going to hold another object inside, and that is called as composition. So we will be implementing these examples. So when we implement the examples, I will like show you how to go about doing it. So in the next video, I'll show you how to implement these examples.